We're gonna go ahead and get started. It's 2:05. Hello, everyone. Thanks for joining us. It's exciting to see you all pouring in over Zoom. We'll be talking about introducing the event QRISE today. My name is Caden Kakmarinsky. I'm directing QRISE. First, before we get into QRISE, we'll give you a quick introduction and background to the Quantum Coalition and introduce ourselves. We'll run through a little bit about the event, and then when we're done, we'll have an opportunity for question and answer session for any burning questions that you all may have. So I'll hand it off to Ben to introduce the Quantum Coalition.
Hi, Caden. Thanks for that. Yeah, so my name is Ben. I'm one of the organizers of QRISE, and I've been involved in the Quantum Coalition since its inception in 2020. So just to give a brief introduction to who we are and what we do, in 2020, a group of undergraduate students at Yale University partnered with students at Stanford University to organize QC Hack 2021, which was an online quantum computing bootcamp and hackathon. It was the middle of the pandemic, and an online hackathon was a great opportunity to connect with other quantum computing enthusiasts. The Quantum Coalition continues to be an organization that seeks to create these connections between people who are enthusiastic about quantum information science. We are a group of undergraduates hailing from various universities, including Yale University, Case Western Reserve, Stanford University, Berkeley, UC Berkeley, the Izmir Institute of Technology, and Princeton University. In 2022, we organized QC Hack 2022, which was another iteration of QC Hack, again, a large online quantum computing bootcamp and hackathon. However, noticing the many professionally organized quantum computing hackathons increasingly becoming available, we were inspired to plan a more unique event. This culminated last year in SQUID, the Symposium for Quantum Undergraduate Inquiry and Discovery, which was an online quantum computing conference targeted at undergraduates organized by the Quantum Coalition. SQUID was a successful event, but we felt that it was missing something, specifically that already having research to present was a significant barrier to entry. We wanted to design events that would make quantum computing research accessible to everyone. And this was the core motivation behind QRISE, an event which allows anyone to get exposure to real quantum computing industry research and to connect with a community of quantum computing enthusiasts. Over the past 6 months, the Quantum Coalition has been meeting weekly to plan QRISE, and we have been coordinating closely with our industry sponsors listed here, including QuEra, the Unitary Fund, Classic, Microsoft, Inflection, and IBM Quantum, to propose real industry research projects that are accessible to people who are maybe just starting to get interested in quantum computing, but also have really interesting and fruitful questions for people who may have more experience. So organizing QRISE has been a very enjoyable experience, and in a second, we will give you an introduction sort of more specific to the logistics of QRISE and how this is going to work. But first, we'd all like to introduce ourselves, the organizers who have worked on QRISE this year. So as I said, my name is Ben. I'm a senior at Yale University. I'm interested in condensed matter and quantum information theory. I'm a physics and math double major. And one fun fact about me is that I enjoy playing the flute and I like rock climbing. My role in organizing QRISE has been as sponsorship outreach, and I'm also the one who sends you the emails. So yeah, and I'm really excited for this event. I'm especially excited to see at the end of QRISE when we get a chance to read all of your submissions and see some of the exciting ideas you've come up with and creative approaches you've taken to solving the sponsors' challenges. So thank you, and I'm looking forward to this.
Jenny, I'm a second year at UC Berkeley studying physics and computer science. I'm interested in quantum hardware and algorithms. And a fun fact, I also rock climb.
Sorry.
And no worries. I'm excited to see everyone, and we have some exciting challenges ready for you guys.
I'm Angela. I'm a sophomore at Stanford, and I'm majoring in engineering physics. Some of my hobbies include skateboarding and drawing, and I've been involved in logistics and outreach. I'm super excited to see everyone's ideas for solving these challenges and excited for a great event.
I'm Thomas. I am a third year electrical and computer engineering student at Princeton. I'm interested in quantum information and applied physics. And yeah, I play and compose music on the side. And regarding QRISE, I helped out with advertising, and I'm really, really excited, like Ben and others have said, to see the projects that you guys come up with within these all of these unique challenges.
Hello everyone, I'm Naz. I'm a freshman year physics student at Izmir Institute of Technology. I'm interested in quantum optics and quantum computing, obviously. And besides that, I enjoy playing electric and bass guitar. I was involved with outreach and advertisement in this event. Sorry, and I'm excited to see you all working and having fun in these challenges. Thank you.
I'm Meher Talati. I'm a freshman at UMD pursuing double degrees in physics and computer science. My interests lie in quantum algorithms and simulation, particularly for high energy physics. So in my free time, I also like to fence and develop games. I worked on speaker outreach for QRISE. I'm really excited to see how people collaborate kind of internationally to solve these projects.
And my name is Caden. As I mentioned before, I am a senior at Case Western, studying engineering physics. I'm interested in really everything related to quantum computing, also AI. My background is in quantum optics. I was on the football team here. I really enjoy sports as well. And I'm really excited just to see building a larger quantum community and undergraduate community throughout this event. I'll start by introducing the QRISE event now and give a little bit of a background on how we came up with this idea and our motivation for the event, and then we'll get into some more specific logistics. So when we thought of QRISE, we wanted to build on what we've accomplished last year with SQUID, and that was moving away from the direct hackathon format where we all meet up one weekend, pull an all-nighter, and do a project. And now there's pros and cons to this. I'm sure we've all experienced them before. It's really a unique opportunity. It gets us involved with work that we care about, but it can be tough as a quick sprint in a weekend. So I've also had the experience personally, I think it's been shared with many of us, at a hackathon where maybe we had a really cool challenge prompt or something that we wanted to expand on, but in a time constraint of 24 hours, we really weren't able to do all we wanted to look into. And then maybe we thought we were going to come back to it and then never did. So that's kind of where we thought of this 6-week time range event. And how we wanted to organize this was working with industry sponsors to get impactful challenges so that we have an opportunity for all of you to get into some important related topics that do have an impact on the current industry. Throughout this 6-week event, we will also have opportunities for engagement, such as workshops directly from the companies and a speaker series where we have some professors from academia talk about just quantum knowledge. Additionally, too, the top groups from each challenge will have an opportunity to present in front of the company that assigned that challenge. So that'd be a really awesome networking opportunity at the conclusion of this event. We'd also like to stress that this is a 6-week event, but we don't expect you to treat this like a full-time job. We're all students, we're all busy. It's okay if you need to take off some time for midterms week or spring break. Now, we still want to put in a solid amount of effort over this, but it's certainly something that can be spread out over time. And really the 6-week window gives us some flexibility. Additionally, with all of our workshops, all of our meetings, anything we're streaming, we will record and post later because we know a lot of us are coming from different time zones and have different availability. So it's probably impossible to make everything, but we'll record everything so that you can follow along on your own time and schedule. Additionally, we already have the workshop schedule posted. We're working on the speaker series, and we'll get those posted soon. We'll additionally send a weekly itinerary each of the 6 weeks through the email setup and the Slack, just so we can keep you guys updated on what's going on and what is the current events. Next, we'll go into some more specific logistics, such as team formation.
Yeah, so for team formation, we've created a Slack channel called Team Formation that you can please join. And this is, again, another reminder to join the Slack. In the email that Ben sent out this morning, there's links for both joining the Slack as a whole and the link for joining the team formation Slack channel. So these are two separate links. So if you're having trouble joining the Slack, you might be using the wrong link, but both are in the email. And then for how to use this team formation channel, it's for both groups looking for individuals and individuals looking for groups. So if you kind of already have a few people in mind to work together, but you haven't hit that 5-person goal, you can post in the team formation channel saying kind of a bit about yourselves and the kind of people you're looking for, so people can respond in thread, and that way it's all organized to keep track of. If you're an individual looking for a group, please feel free to post a message about yourself, kind of what you're looking for in this event and what you have in mind, and that way people can reach out to you directly as well. If you are struggling to find a group, we will be releasing a form at the end of week 1, probably around Thursday, for us to manually match you to a group. And that way we can finalize groups by week 2. But again, we highly encourage that you do use the Slack channel function to look for a group yourselves and really use the form as a last resort.
And then we have some exciting workshops to accompany each of the challenges from the 6 companies that are helping sponsor or partnering with us. And they'll help you get acquainted with the challenges and also provide you with the tools necessary to kind of succeed in them. They'll be on Zoom and be recorded, and these links will be posted in kind of that weekly itinerary and also in the Slack channels. And we have Microsoft on Tuesday and Classic on Wednesday. So make sure to tune in for those kind of workshops and get started.
Like Kaden mentioned, alongside the workshops, we'll also have academic speakers to talk about the latest in quantum computing research and short lectures. I'll make sure to keep an eye out for those to get a sneak peek into what's happening on the frontiers of quantum and take a deep dive into topics that might help you work on a challenge. Speaker dates and times are still being finalized, but expect to see them posted soon.
Additionally, I do want to mention really quick because I see a couple questions coming in the chat. We'll be sure to pin a message in the Slack and send out an email after this meeting to make sure the Slack link is still working. And with the weekly itinerary we send out this week, which we'll try to send out each week by Monday morning to early afternoon, we'll be sure to include another Slack link as well if it doesn't work out. Additionally, I do want to mention now what the submission instructions will look like and how this event will wrap up just for planning purposes. So the conclusion of the event will be April 12th. We're opening up the challenges tomorrow morning, March 4th. So you have a 6-week period to work on these challenges. What we will do too is the workshops will be about a 2-week period. So throughout this period is a good time for building teams. We would suggest to get your team formed as quickly as possible, as Angela mentioned. One suggestion we may have is if you have a local club, if your university has a local club, you could try to form teams that way. Maybe a local event type of QRISE kickoff event would be in store there, and that would be helpful. Otherwise, the team formation challenge will help pair from across the world. And for anyone who doesn't end up in a team throughout the week, we will have a form coming out at the end of the week, like Angela mentioned, to help pair up anyone who is teamless or needs an extra member at the end of the week, just so we can ensure that you're all ended up with a good team. Additionally, at the end of week 2, I don't know the exact date now, but after the end of the 2nd week, we'll only have 1 workshop left, but that's when we're going to close team registration. So you have your first 2 weeks, and anyone can still join after 2 weeks, so it won't be late. And so anyone, you can figure out your teams and finalize. But once you submit your registration form, we just request that that's final. So putting in your team members' names and which challenge you'd like to work on, and then that will be finalized throughout the event. If there is any type of need for like changing a challenge, or if you have extenuating circumstances, Ben, you want to mute all quick?
Yeah, sorry. Sometimes it's hard to find in the link. Sorry, continue. Kate.
Yeah, no worries. Thank you. But where was I? Yes. If there's extenuating circumstances or you need to change challenges or anything happens, feel free to reach out to us on a case-by-case basis. We'll be more than happy to help. Specifically, you guys are already familiar with Ben because he's been sending you all the messages, but feel free to look up my name or any of our organizers' names in the Slack or via email, and we'll be able to help out with anything. And yes, we are asking for you to only do one challenge and submit it. We wouldn't like you to do like all of the challenges. If you just could work as a team on one challenge, that's kind of what we're looking for here. And then for the conclusion of the event, the max number of people in a team will be 5. So we're looking for teams of 5. Teams can be smaller if you want to go solo, or maybe you want to work in a group of 3 or 4. That's okay, but the maximum number is 5. We do encourage try to go for a team of 5, but anything less is also okay. So the conclusion of the event will be April 12th, and the deadline for submission will be 5 p.m. Eastern on April 12th. That is a Friday. What we're looking for submissions that week, we will put out a Google form in which you will turn in your team members' names and your challenge, as well as we're looking for a 5 to 10 minute PowerPoint or just any type of video presentation of just walking us through what you learned, what you did, and your journey of QRISE, as well as any type of deliverables or code that you made. Some of the challenge descriptions will have more specific instructions, such as like a Jupyter notebook or some type of Python code for specifically what you're doing. So we'll have a GitHub link where you can submit your GitHub repository, a video upload, as well as your names. That will be how submissions will work. And then after April 12th, us, the organizers, will go through the submissions and pick out the top few from each category, and then give you an opportunity to set up a presentation with the company who proposed the challenge. So now that we've addressed a lot of these logistics, we can get into talking about the challenges. So we have some pre-recorded videos from some of our challenge sponsors to give a little bit of background on the challenge, to give you guys some hype before we release the full challenges in the GitHub tomorrow. So Thomas will introduce our first challenges.
Yeah, thank you, Caden. So our first video will be from QuEra, which is a neutral atom quantum computing company. And their challenge is, well, for some context, they talk about in the race between nature and experimenters to find ways to protect quantum information against noise. Neutral atom technology has taken a step ahead with the ability to implement non-local operations and measurements. And so in this QuEra challenge, you're going to develop new perspectives on quantum compilation required to exploit this feature of protecting quantum information against noise with non-local operations and measurements. And so here is the video.
QuEra's Quantum Advocate, and I'm here to introduce you to QuEra's challenge for QRISE 2024. In this challenge, you join our efforts in one of the most exciting times for quantum computing since inception. We're going to be working on bringing quantum error correction to reality. Late 2023, in a collaboration led by researchers from Harvard University, we have shown that quantum computers based on neutral atom architectures are capable of performing complex algorithms with logical qubits. While the path for large-scale fault-tolerance quantum computing is long, a sensible route is set, and we are making the first steps on it, trying to bring error correction to the community this year. This is one of the most exciting and most important missions we have had so far. And one of the hardest parts of this is that, as usual in quantum technology, highly performant algorithms require tight connection with hardware. Neutral atom quantum hardware present us with large numbers of high-quality qubits with high-performant 2-qubit gates, but perhaps even more important, it allows for any-to-any reconnection of those qubits via atom shuttling. It allows us to perform highly parallelizable logical gates via transversal gates, and all of that happens on top of a platform highly functional with independent zones. Altogether, this means that the design space for efficient encoding of algorithms is huge. Your challenge, if you're willing to take it, is going to be to create tools that support intuitive and hardware-aware design of algorithms and compilation. These tools can include visualizers, they can include reporting tools and protocols, for example, for fidelities, time to solution, or energy consumption. And they can also include such things like embedders for different types of error correction strategies to allow users to rapid benchmark their algorithms with different error correction protocols. We call this a logical qubit simulator. Making logical algorithms intuitive and highly functional is an open research question to which we don't even know if there is one best single solution. QuEra is definitely working on our own version of this, and we are keen to see what you believe is going to be the necessary tools to bring us to this next new logical era of quantum computing. Hope you join our challenge, and good luck!
Yeah, so that was QuEra. Up next, we have Inflection, a company that also works with neutral atoms, but as well as quantum software. And as per their description, the first quantum revolution rocked the world with barcode scanners, transistors, and high-precision atomic clocks. So in Inflection's challenge, the first and second quantum revolution come together by merging quantum computing and quantum metrology to benefit real-world technologies. So here is the video from Inflection.
Hello, my name is Victor Mole, and I'm a quantum software engineer at Inflection. So the background of my challenge is that basically we're all trying to find practical applications for quantum computers, but it's really difficult. But the thing is, there are, quantum computers do have applications to physics. So in this case, my challenge is to apply using quantum computers to design better atomic clocks. And this is just a first step in using quantum computers to improve other quantum technologies like quantum receivers and quantum Bose-Einstein condensate machines. All things that Inflection has. All these things Inflection has as products. So yeah, I encourage you to sign up for the challenge and have fun.
All right. And next is Classic, a quantum software company. As per their description, efficiency is key for quantum speedup, especially in noisy near-term devices. In Classic's challenge, you're going to leverage their compilation algorithm to bring exponential quantum speedup into view by investigating a quantum simulation algorithm known to achieve an advantage over its classical counterparts. So here is Classic's video.
Hi everyone, I'm Eden, the Director of User Growth and Quantum Community here at Classic, and I'm really excited to present Classic's challenge for QRISE 2024. So let me share the screen. So your challenge will be to implement actual quantum algorithm, one of the few quantum algorithms that give exponential quantum advantage for interesting and real-life problem. And this is the paper that you will follow and you will need to implement. So you need to come with an implementation using the Classic platform of this state-of-the-art algorithm of exponential quantum speedup in simulating coupled classical oscillators that was published a few months ago in PRX, one of the most prestigious journals in quantum computation. So let me give you a brief overview of what is Classic. So Classic is an end-to-end quantum software platform that enables you to design, to optimize, to analyze, and to execute quantum algorithms. So it's a web-based IDE that you can just go to platform.classic.io and use everything. And there is an accompanying SDK package that goes one-to-one correspondence with the IDE. So you can just get started by yourself even before the workshop that we will have. Just go to platform.classic.io and sign up, and you can install the Python SDK package. So when we design novel quantum algorithm Classic, there is a dedicated modeling language that you can use within the framework of the web-based IDE. And you can also design everything with the Python SDK package. We have all the documentation that explains you how to use and come up with new quantum algorithms and quantum functions and everything. And once you have the implementation of the algorithm using either the SDK or the modeling language, you can synthesize, you compile the algorithm into a circuit level implementation, and you can compose some constraints and preferences like maximum width or maximum depth, or to optimize the algorithm to a specific implementation. And you can do both, again, or from the web-based IDE or from the Python SDK. And it utilizes, again, the high-level functional design abilities of the classic platform, which is really strong. Once you optimize and compile and synthesize the quantum circuit, quantum algorithm to a quantum circuit, you want to analyze it. And then there is a really, really powerful visualizer within the platform IDE. And then you can zoom in and zoom out and see the circuit implementation on different level of hierarchies according to the functionality of your algorithm that you design. And it's really a powerful tool in analyzing and understanding and debugging your algorithm. And once you have the circuit implementation itself, you want to execute it either on a real hardware or on a simulator, and you can do everything within the platform, within the classic platform, from the IDE or from the SDK, both ways. And the jobs will be waiting for you, the result will be waiting for you within the classic platform. You don't need to wait online once you send the results, and then you can download and post-process in whatever you want. So I encourage you to start exploring it even before the workshop. Just go to platform.classic.io and you can do everything from there. So in addition to the presentation, you'll get the one pager that summarizes the specific challenge, and you can go over it, and there is some recommendation of how to get started. So good luck, and I'm really excited to see the results that you'll come with, and we'll see you during the program. And keep asking questions in our Slack community, which is really active and helpful for people to understand and come up with new ideas and everything. And looking forward to meeting you all.
Wonderful. Can you hear me? Okay, awesome. Yeah, so the next challenge we have to introduce is the Unitary Fund. And the Unitary Fund, unfortunately, was not able to send us a video, but we're happy to share the content of the challenge with you. So part of the Unitary Fund's research strategy is to make near-term quantum computers more viable by improving them with error mitigation. So the QRISE 2024 Unitary Fund challenge involves stacking together quantum error mitigation techniques. So in this research challenge, you'll explore the efficacy of stacking multiple quantum error mitigation techniques by leveraging the MITIC Python toolkit. The goal is to compare different combinations of error mitigation strategies in simulation to achieve the lowest possible error rate. Quantum computers hold an immense potential for solving complex problems, but their practical utility is hindered by their susceptibility to errors. Mitigating these errors is crucial for realizing the full capability of quantum computers. This challenge aims to find effective methods for reducing the noise by means of combining multiple quantum error mitigation techniques. Quantum error mitigation is a field of research that aims to find ways to increase the accuracy of quantum computers without the full machinery needed to implement quantum error correction. A plethora of quantum error mitigation techniques have been proposed and studied over the past 7 years, and yet the capability of these techniques have not been thoroughly tested and explored in conjunction with each other. Recent work in layer-wise Richardson extrapolation is exciting and is currently being added to MITIC. Adapting some of the available code could be useful in increasing the performance and achieving improvements by coupling different techniques. The Python toolkit MITIC contains many of the popular error mitigation techniques, and various QEM stacks, i.e. combinations of these techniques, could be simulated on a suite of benchmarking circuits with different noise models to get a sense of how each stack performs in a wide variety of situations. So this is the statement of the Unitary Fund's challenge regarding error mitigation, very applicable to improving the viability of near-term quantum computers, and we hope that you'll consider signing up for this challenge.
Next challenge is from Microsoft. Its proposal is to obtain estimates of quantum qubit numbers and noise thresholds for various quantum algorithms and error correction protocols using the Microsoft Azure Quantum Resource Estimator. And here's the video.
My name is Maria Mikhailova, and I'm a principal quantum software engineer here at Microsoft Quantum. Our research challenge for QRISE 2024 is resource estimation of quantum algorithms. Quantum resource estimation is the area of quantum information science that answers the question, how many qubits and how much time does it take to run a quantum algorithm on a certain quantum hardware platform? The answers are estimated under realistic assumptions about the architecture of fault-tolerant quantum computers, such as the gate application times, the error rates, and the error correction scheme used. This kind of estimates allows us to answer multiple questions. First, it allows us to define the requirements for quantum hardware that it needs to satisfy to be able to run certain algorithms. Second, it allows us to figure out which of the quantum algorithms actually offer quantum advantage over their classical counterparts and which ones do not. And third, it allows us to compare quantum algorithms and their efficiency a long time before we can run them on quantum devices. This kind of information is vital for us to get as we define our vision for the future of quantum computing. In this challenge, you will choose a quantum algorithm, implement it, get the resource estimates for it, and analyze them. In short, you will do all the steps of the work of a quantum algorithm researcher. I hope you learn a lot as you work on this challenge, and just as importantly, have fun.
And the other challenge is from IBM about dynamic circuit challenge. Quantum teleportation is among the most amazing applications of the principles of quantum information. Crucially, it relies on communicating classical information through a measure and feed forward protocol. Such protocols can help quantum computers to generate entanglement faster than unitary circuits alone. So, in this IBM's challenge, you will explore how to model and understand this interesting class of circuitry.
Welcome to this year's QRISE challenge. I am Haimeng. I am a quantum software developer and engineer at IBM. This year's challenge is centered around dynamic circuits. It is a feature that was introduced to IBM quantum hardware in 2022. With dynamic circuits, we can not only do quantum gates, but also utilize real-time classical data processing. Imagine we can now measure in the middle of a circuit, store the measurement outcome to classical bits, and then evaluate classical expressions. And after that, update the subsequent quantum gates to apply accordingly. I got very excited about this feature when it was first introduced because it is a very important step towards quantum error correction. So I hope we use this challenge to introduce you to the realm of quantum computing and learn about the state-of-art research in quantum. Pick a problem that you are excited about and make use of quantum circuits with this dynamic feature to solve your problem. I think team collaboration will be essential to your success. And when you have questions in programming Qiskit, do not forget there is a very active community on the Qiskit Slack channel where you can post questions and bounce off ideas. Well, good luck, and most importantly, have fun.
All right. There's the recap or preview of our great challenges from our awesome partners and sponsors from the industry that proposed our challenges. One comment I'd like to make now that you guys have seen a little intro into the challenges is some of these challenges are a little bit more open-ended than what you'd see at a normal hackathon. And that is on purpose because you have 6 weeks instead of a weekend. One thing I want to mention is I would recommend reading through all of the challenges, seeing which different topics are, and as they all mentioned, like pick something you're interested in. We try to choose a variety of topics And all of these topics are impactful and are directly tied to what these companies are currently doing. So all of these are going to be useful skills, things that will be great to learn and good things to talk about in the future. And I do want to remind you that the final deliverable is a video presentation on what you've done and what you've learned. So don't be afraid to fail. You could pick something ambitious. You may prove that something doesn't work, but just enjoy the process and look into whatever is interesting to you.
All right, thanks so much. Well, so just in closing, before we start the Q&A, we'd like to wrap up by thanking all the representatives from our sponsors that helped to make this possible. So from QuEra, you heard Pedro Lopez, who we've worked with closely and who's been fantastic in helping design this challenge and in bringing QuEra's research close to us. At Inflection, we'd like to thank Stephanie Lee and in Victory Omole, who was great to work with in designing this really creative challenge. And at Classic, we'd like to thank Eden Sherman, who you heard speak, and Ron Cohen, who's going to be giving the Classic workshop. At the Unitary Fund, we'd like to thank Nate Stamen. And at Microsoft, we'd like to thank Maria Mikhailova, who you heard speak just a second ago and who will be giving the first workshop. And then lastly, at IBM, we'd like to thank their team, including Marina Caputo, Nate Ernst Noble, who helped originate the idea for the challenge, Ana Maria Rojas, and Luke Govia, who will be giving the workshop. All right, yeah, unless Katie, you want to say anything else in closing, we can wrap up this portion and start the Q&A.
Yeah, I think that sounds good. We're all super excited for this event. We're excited for you all to experience some quantum research. One thing I guess we could note too is in the Slack, we have different channels for each challenge. So for instance, if you do the Unitary Fund challenge, the Unitary Fund challenge channel in Slack. So please use these challenges, challenge Slacks to talk to other people, maybe ask questions. I mean, I wouldn't suggest giving away exactly what you're doing, but vague questions or anything about the prompt, go ahead and share. I believe we'll do our best to be attentive to any questions that we see arise. Just from a pure number standpoint, it may be impossible to get every message answered, but we'll absolutely do our best, and we'll try to get our sponsors in there as well for feedback and anything you may need. Additionally, anything else you may need, just reach out to us on Slack, on email. Ben, myself, and the rest of the organizers we'll be happy to help.